right, welcome to the screencast for objective number 4 and number 8. We're going to convert between mass, which is in grams, number of atoms, moles, and volume in liters using dimensional analysis and conversion factors. My advice to you, if you need to go back and review how to do dimensional analysis, this short 4-minute video is great. Just reviewing how to set up dimensional analysis problems. So our essential question, how do we convert between moles, mass, atoms, and liters? The first thing I'm going to take you through is we are going to use dimensional analysis. So you're going to have units on the top and units on the bottom that we're going to cancel using like the train tracks method to convert between these units. These are your 3 conversion factors. I will give you these. You just have to know how to use them. 1 mole is 6.022 times 10 to the 23rd atoms. I can use this one to go from moles to atoms or atoms to moles. 1 mole equals the molar mass in grams, which you've already learned how to calculate, so you have to use your periodic table for that. And 1 mole is equal to 22.4 liters of a gas in terms of volume. This only works for gases. This does not work for liquids and solids. So I have this educreations video that I made, and I'm going to go back to it here in just a second. But I'm going to take you through the next slide first. These are 8 examples. I am going to work through 4 of them in the educreations video for you that I'm going to play. We are going to do a lab activity. We are going to work practice problems. So over the course of 2 days, we're going to do a lab and practice problems. So your template or your summary format is template number 1 for both of these objectives. And I'm just going to go back and play this video of me working 4 out of those 8 problems. Here's an educreations video to show you how to do some basic conversions between moles and grams and atoms and liters. This goes with our stoichiometry unit. So I'm going to work through some of the problems that are in the objective notes. So I'm going to work through very specific problems just to give you an idea of how to set these up. So the first problem, number 1, in the PowerPoint says I have 5 moles of water and I want to know how many atoms that is. So I have 5 moles of H2O, and I want to know how many atoms that is. Well, I know I have this conversion between moles and atoms. 1 mole is 6.022 times 10 to the 23rd atoms. So I'm just going to set up my dimensional analysis to go ahead and solve for this. So I have 5 moles of H2O. Whatever unit I have on top is the unit I have to have on the bottom. So moles to atoms. And I know in 1 mole there's 6.022 times 10 to the 23rd atoms. So because it's across the top, I'm going to multiply and I divide by what's on the bottom. So I'm going to cancel out moles and now I'm left with my unit of atoms. When I plug this into my calculator, I get 3.011 times 10 to the 24th atoms. But I can only have 1 sig fig, so my answer is 3 times 10 to the 24th atoms. The next problem I'm going to do for you is number 3. Number 3 says I have 5.00 grams of H2O, and I want to know how many moles that is. So in this case, because I have grams, I'm going to have to find the molar mass, because I know that 1 mole equals the molar mass of whatever I'm working with. So the molar mass of water, 1.0079 times 2 plus 15.9994, the molar mass of water is essentially 18.02 grams. So I'm going to use this number as my conversion factor. So I have 5 grams of water that I'm starting with. If I have grams on top, I have to have grams on the bottom. And I know that there's 18.02 grams of water in 1 mole of water. So by solving this, I multiply across the top, divide by the stuff on the bottom. So I take 5 times 1, which is still 5, divided by 18.02. I cancel out my grams, and I'm left with moles, which is what I want. My answer out of my calculator, I get 0.2775 moles. But I can only have 3 sig figs, so 0.278 moles of water. So 5 grams isn't quite a mole, which makes sense. I would need 18 grams to have 1 mole of water, and I only have 5, so not quite there. So the next one I'm going to do is problem number 4. Problem number 4 says I'm starting with 8.62 moles of potassium, and I want to know how many grams that is. So, like if I were to weigh it out on a scale, how much would 8.62 moles of potassium weigh? Well, because I'm dealing with grams again, I'm going to need to have the molar mass. And since this is just an element, I look on the periodic table, and I see the molar mass for potassium is 39.0983 grams per mole. So that's what I'm going to use as my conversion factor. So 8.62, which is my starting number, moles of potassium. If I have moles on top, I have to have moles on the bottom. And I know in 1 mole, there's 39.0983 grams. So I have 8.62 moles. I'm just going to multiply that by 39.0983 because that's how much 1 mole weighs, and that'll tell me how many grams I have. So when I multiply that out, I get 337.02 grams. I can have 3 sig figs, so 337 grams of potassium. So if I said, go get me 8.62 moles, you would go get me 337 grams. That's what you would weigh out. The last one I'm going to do is number 6. It says I'm starting with 3.25 liters of CO2, and I want to know how many moles that is. Well, I have this conversion between moles and liters, at least at standard temperature and pressure, and it tells me that there's 22.4 liters in 1 mole. So 3.25 liters of CO2 is what I'm starting with. If I have liters on top, I have to have liters on the bottom. I know there's 22.4 liters of anything in 1 mole for a gas. So all I do then is cancel out my units. I'm left with moles. 3.25 divided by 22.4, and I get 0.145 moles of CO2 out of my calculator. I have 3 sig figs, just like that number, so I am done. Okay, that's the end of this particular screencast. We will work through these. My advice to you is to try some of these other ones on your own and see if you can do them. So that way when we work through them in class, we might be able to identify what it is you're doing wrong in your setup or what you might be doing right. And again, the summary format is template number 1.